Hey y'all, today we're going to be talking about solving systems of linear equations by substitution. Substitution is going to be the second method that we're going to learn. So we've already learned how to solve them by graphing the two functions, and then looking for that point of intersection. Today we're going to learn how to solve it by substitution. And substitution stands for plugging something and substituting a value in for a variable or for something else in the equation. So what we're going to do is we're actually going to substitute an entire equation in. But let's kind of talk about that. It's a weird thing to think about just by saying it. And let's actually look at an example. So we have y is equal to 3x minus 13 and 4x plus 5y is equal to 11. So right off the bat, you probably notice these aren't both in y equals form. So if they're not both in y equals form, then substitution is already something that should be on the table, because sometimes it can be a little easier than solving into y equals and then graphing them and so on and so forth. Okay, so our step one for substitution is to solve one of the equations for x or y, or essentially solve one of the equations for a variable. We want one of the equations to have a variable by itself. It doesn't have to be both, it just has to be one. And so the reason why substitution can be so good sometimes for these situations is because we already have one of our two equations that's solved for a variable. We have y is equal to 3x minus 13. So step one is already done for us. Okay. Step two is we're going to plug in or substitute what that variable equals in for the other variable in the second equation. And once we do this, you should only have one variable in your new equation, and we're going to solve for that variable. So let's look at example one. So I'm going to take y equals 3x minus 13, and I'm going to plug it in to y in my second equation. So I'm going to take that y equals 3x minus 13 and plug it into that equation. So this is going to become 4x plus 5 parentheses 3x minus 13, because I know that y is equal to 3x minus 13. I'll make it a little easier. We'll say we're just plugging this part in for y. Equals 11. So everything else stays the same. I'm just replacing y with what I know y equals. And if I did my job right, then I should only have one variable in my new equation. So I should now only have x because I replaced y with what I knew y to be. Okay, and now I'm going to solve for x. So my solving steps, I have a set of parentheses, so I'm going to distribute the 5. So this becomes 4x plus 15x minus 13 times 5, and you can always use your calculator for numbers like this. 65 is equal to 11. Before I move on, I have some like terms, so I'm going to take 4x and 15x. 4x plus 15x is equal to 19x minus 65 is equal to 11. And then from here, I'm still trying to solve for x, so my next thing I can move is my 65, so plus 65 plus 65 cancels out over on the left. 11 plus 65. Remember, you can always jump to your calculator. There's never any shame in using your calculator. So 19x is equal to 11 plus 65 is 76. And then last step, I want to still get x by itself, so divide by 19. And I know y'all probably don't know 76 divided by 19 in your head, so just type in your calculator real quick, 76 divided by 19, and we get x is equal to 4. Okay, so that is the first half of our answer for example 1. Okay, for the second part of our answers, now we're going to take the value or the answer you just got and plug it into one of the original equations to solve for the other variable. So I'm going to take my x is equal to 4, and I can actually plug it into either equation to solve for y. Now, between my two equations, there's one that's a little bit easier. It makes the most sense, and it's going to be the one that's already solved for y. Y is equal to 3x minus 13, because I can just plug in 4 and then just simplify out those numbers and be done. I don't have to do any of my solving steps. So y is equal to 3 parentheses 4. I'm replacing x with 4 minus 13. So y is equal to 3 times 4 is 12. 12 minus 13. So y is equal to negative 1. So that's my x value, my y value. Okay, just like on our last one, we write our answer as a point or as an ordered pair. So we take both of this information and write it as the point 4 comma negative 1. Okay, because even though we're doing a different method, our final answer is still the same thing. It's still that point of intersection, which we write as an ordered pair. Okay, so that's substitution. So just kind of a recap of our steps. We check to see one of our equations is solved for a variable. Then we take that equation and we plug it in for that same variable in the other equation. Then we simplify from there to solve out for our variable. We take that value we get for that variable and we plug it into either of the equations, whichever one's going to be easier to get that final answer. And then we write both of those two numbers as an ordered pair. Okay, let's look at some more examples. So let's look at number 2. Okay, we have y is equal to 3x minus 8 and x is equal to negative y plus 4. So it does not matter which one here that we actually plug in for. Really doesn't. Okay, so I could plug y in for y. I could plug x in for x. Totally doesn't matter. Let's just switch it around. This time we're going to plug x in. So I'm going to take negative y plus 4 and I'm going to plug it in for x. So we get y is equal to 3 parentheses negative y plus 4 minus 8. Then I'm going to be solving for y, which notice once again I only have y in my equation. So y is equal to 3 times negative y is negative 3y. 3 times 4 is 12. Minus 8. I do have the like terms of positive 12 and negative 8. So 12 minus 8 is equal to 4. Okay, from here, I can move my y's because right now my y's are on different sides. So I'm going to add 3y to both sides. So we get 4y is equal to 4. Divide by 4, divide by 4, and we get y is equal to 1. Okay, so that was step 2. Step 3, I take y is equal to 1 and I plug it into either equation. The one that's already solved for x is probably my better bet. So x is equal to negative 1 plus 4. Negative times 1 is just equal to negative 1. So x is equal to negative 1 plus 4. Negative 1 plus 4. We get x is equal to 3. And so as our final answer, x value of 3, y value of 1, so we get 3, comma 1. All right, pretty straightforward. Like I said, as long as one of them is solved for x or y, substitution is going to be your best bet. If both of them are solved, like they're both y equals, then graphing is probably going to be a better choice. So as we learn all these methods, you're going to start recognizing, oh, this is one that's best for elimination, or this is one that's best for substitution, or this is one that's best for graphing. And you can kind of go from there. Okay, let's keep working through these. Get a little more practice. So we got example 3, y is equal to 6x, and y is equal to 28 minus x. So these are actually both solved for y. So graphing might be a better choice here, but we're going to do substitution anyways, just so you can see that even if one's set up for another, you can still use one of the other methods. So if you just love substitution after today, you're like, wow, Mr. Arbone, substitution's easy, then you can always do substitution as long as one of the equations is solved for a variable. So we have y is equal to 6x. So I think that one's a little easier to plug in. So I'm going to take 6x. I'm going to take 6x, and we're going to plug it in for y in the other equation. So we get 6x equals 28 minus x. Nothing to distribute, nothing to combine like terms. All I got to do is add x to both sides. So plus x. We get 7x is equal to 28. Divide by 7, and we get x is equal to 4. Okay, that's our first piece. Second piece, I got to take x is equal to 4 and plug it back in. Both of my equations are set to y equals, but I think y equals 6x is still a little simpler. So y is equal to 6 times 4. So y is equal to 24. And then as our final answer, we write this as an ordered pair. So 4, 24. Okay, I'm going to let y'all try number 4 on your own. So if you want to, go ahead and pause me real quick, and you can do number 4 on your own, and then we'll come back and do number 5 together. So go ahead and give me a pause. All right, also, hopefully you worked through that one, and you probably ran into a little bit of a stopping point because like, wait, I got 0 over 0, or 0 equals 0. Did I do something wrong? You didn't do anything wrong. So something you might not know is if you solve both of these equal for y, you get the same equation. Y is equal to 1/2 x minus 3. So these are actually the same equation, and we talked about this last time. If you have the exact same equation for both of your two linear equations, the answer would be infinite solutions because they touch each other everywhere. Okay, now let's talk about this algebra result though. So when we get 0 equals 0, our variables cancels out. That means that no matter what numbers we plugged in for x and y, this statement of these two equations would always be true. Okay, so because of that, because it's always true, that means it has an infinite number of solutions. I could plug in any solution along these lines, and it would be true still. Okay, so that's what we say when we mean infinite solutions. If instead you get a similar result where your x's or your y's cancel out, but we get an false statement. So instead of like 0 equals 0, you get like 1 is equal to 7. Okay, that's not true. Then you would get no solution. That means there's no way to solve those two equations because they're parallel. Okay, so let's do number 5 together. Number 5, we get 2x plus 4y is equal to 10, and 2y minus 4x is equal to 4. So it doesn't matter which one, but we have to solve one of these equations for y. So let's just do the bottom one because it's a little easier to write. So I'm trying to solve these for a variable. Let's go ahead and solve it for y because y is already positive. I don't have to worry about dividing by a negative. So plus 4x plus 4x. We get 2y is equal to 4 plus 4x. Divide everything by 2. And we get y is equal to 2 plus 2x. And then I can go ahead and plug this into the other equation. So 2x plus 4, parentheses 2 plus 2x, is equal to 10. So distribute that 4. We get 2x plus 8 plus 8x is equal to 10. So some like terms, 2x and 8x add together to give us, not still red, 10x. And then we still have our plus 8 on the other side. We can subtract 8 from both sides. So we get 10x is equal to 2. Divide by 10, divide by 10. And that gives us x is equal to 2/10, reduces down to 1/5. Okay. Then from here, our number's a little gross, so that means our y number is also probably going to be a little gross. Okay, so x is equal to 1/5. I want to go ahead and plug it into my equation that I have as a y equals equation. So y is equal to 2 plus 2 times 1/5. So that gives us y is equal to 2 plus 2/5. Okay, to be able to add these fractions together, I have to have a common denominator. So the least common multiple of 1 and 5 is 5. So I can multiply 2 over 1 by 5 and 5. So 2 times 5 is 10, and 5 times 1 is 5. So 10/5 plus 2/5, which gives us y is equal to 12/5. So for our final answer on number 5, we have 1/5, comma, 12/5. And that's it. So usually they're nice and pretty numbers, but every once in a while, you'll get one that has some kind of difficult math. But you can always check this. Remember, we can use our calculator. We could graph these equations, and we could check it in our Desmos calculator. If you're not quite sure, if you get 1/5, 12/5, and you're like, I don't know, those answers look weird, you can always check it in your Desmos calculator. Okay, y'all, that is solving linear equations by substitution. We got 2 methods down, 1 more to go in a couple of days.